Okay, so let's say we have a circle, which is this round object here. Well, actually, I can be a bit more descriptive than just saying that it's a round object. I can say it's a set of points that are all equally distant from some common point, which we'll call the center. So the center of circle to the circumference, or just the circle itself, it's the same distance, no matter where we're going to on the circle. And we call this distance the radius. And let's say I make a circle and I call its radius 1. So everything on this circle is 1 unit away. I can describe any point on this circle in terms of its Cartesian coordinates. So I could set a Cartesian plane and center it at the center of the circle. And I can say, well, it's b units across and h units up. So b for base, h for height. And I can give it these two-dimensional coordinates. Equivalently, I could describe it with just one ordinate, the single theta, the angle. The angle that is made between the positive x-axis and the point. And to see why it's possible to describe any point on this circle with just one dimension, we can recall our sine and cosine ratios. So remember that sine is opposite over hypotenuse. In this case, the opposite side is the height of the triangle that's formed, so the opposite to the angle is the height. The hypotenuse is 1, so sine of theta is just 1. Sine of theta is h, the height of this point. Equivalently, we can discuss the x-ordinate in terms of cosine of theta. So cos is adjacent over height. The adjacent is the base, the hypotenuse is... adjacent over hypotenuse. The adjacent is the base, the hypotenuse is 1, so cos of theta is the base. So these two, this coordinate, base and height, could just be represented with a single variable, namely theta. And we can get these two by taking cosine of theta and sine of theta equivalently. This is the concept behind the unit circle. I'm sure you're very well equipped with this, and you should be well acquainted with this idea if you study mathematics. I can use this to find the double angle identity. There's actually I'm not sure if this is recorded elsewhere, but I was thinking about it. I couldn't sleep one night, and I thought, what if I wanted to find the area of this triangle? Well, the area is just half base times height, which equals half cos theta sine theta. Okay, that's the area of one of these triangles. What if I wanted the area of two of these triangles? So let's say I kept the triangle exactly the same, but I just reflected it. Well, let's see if I can do this with one hand. Will I hold the webcam? Probably not. Fairly decent. Fairly terrible, actually. So if I wanted the height, the area of two triangles like this, well, really this triangle is going to have the same area, right? If I took cosine of this angle here, it'd be the x. If I took sine, it'd technically give me a negative value, but we can just say, well, if it's negative, we'll just take the absolute value afterwards. Well, the area of this whole thing, so A of just one triangle is this, but the area of two triangles is going to be double this, which is just cos theta sine theta. And that makes sense, right? Of course it's going to be that. Okay. There's another way to find this area though, because what if I rotated my circle? Okay, and now I say, well, what if this is my new x-axis? So this point here is now my new x-axis. Or this line, sorry, is my new x-axis. Well, then the angle here is 2 theta, right? And the height of the circle is given by sine of 2 theta. So now I can also find the area by treating this as the base of the triangle, and the perpendicular height of the triangle is given by sine of 2 theta. That's what sine does in the unit circle. It gives me the perpendicular height. So this area is also equal to this base, which was 1, times the perpendicular height, which was sine 2 theta, but area is base times height over 2, so I need to divide this by 2. Well, that's equal to half sine 2 theta. Oops, let's point that over there. This and this are the same. These two things are the same value. So we have cos theta sine theta is equal to half sine 2 theta, or as we are more used to seeing this relationship, 2 cos theta sine theta equals sine 2 theta, which I think is a neat little way to demonstrate this fact. Right? We often see it with just using the angle sum identities, but thinking of it in terms of an area just gives us a different way to look at this problem. Why did I think to do area when I was thinking about this? Well, when you're multiplying two things, often you can try and think of that as being an area. So I was just thinking, well, what area would that be if I was doing cos of theta times sine theta? Well, that is just this area of, or double the area of this triangle here, which is precisely this whole thing. So cos theta sine theta is this whole thing, but I can also find that area, as I said before. Just treat this as a new axis, my x prime maybe. The base is now 1 because my hypotenuse is 1, and the perpendicular height is sine 2 theta because sine gives me the perpendicular height along a unit circle. I just repeated myself, but yeah, it's cool. It's interesting.